You still see my screen? Any questions so far? It looks like there are no more questions. So we'll go ahead and switch the topic to cloud security. If you don't see my screen. If someone has question. Okay, no questions, so we'll move on. So we're going to switch gears and then move into a different topic, which is cloud security. We're going to talk about some strategies and implementations in cloud security. Originally, when I was building these slides, I thought of pulling one of the cloud service provider into these slides. For example, whether it's AWS or Azure or GCP, I have skills in all three areas. And then I thought it might probably be not fair to promote one cloud service provider over another. So I kind of made it more generic towards cloud. And today we're going to talk about fundamentals of cloud security. The security controls and in cloud environments, threat detection, monitoring, and incident response, and how do you build, the secure DevOps and compliance, and the same time zero trust model, right? So that's the key in today's security world. Now, cloud in general, I don't know how far everyone is familiar with cloud. We are going to probably consider the top 3 CSPs, what we call cloud service providers. AWS has a major share, followed by Azure, and Google is improving its footprint greatly because of the AI disruption that's happening. Google Gemini LLMs are pretty popular in the market now for business use cases. So we're going to keep these 3 cloud service providers in mind and then talk about cloud security. And cloud itself, to me, is a semester-long subject or even more. If you want to really learn about cloud, I've been working in this industry for past 7 years in cloud. So my take on cloud is probably different because I've seen so many practical implementations, failures, learning from failures, and then improving it over the time. And this is for mainstream applications for large financial and insurance companies that I support. So I'll give you my view from industry point of view, right? So practical, right off the ground view in terms of cloud security. And feel free to interrupt if you have any questions. So cloud, by general, compared to your traditional data centers, they introduced a very powerful word when they were selling cloud. It's called shared responsibility model in cloud environments. So the responsibility, as it says, shared responsibility, the responsibility is shared between the consumer of the cloud and the provider of the cloud. If you take AWS, for example, there are certain areas where Amazon is accountable for taking care of security. And then there are some areas where the customer is accountable for taking care of security. If I'm building an application and a database and hosting it in cloud, it is my job to secure my applications. It's my job to secure my data. And when it comes to Amazon, it's their job to secure the infrastructure that they are providing, to ensure the service level agreements are met on the services that they are providing, which I'm consuming. So that's how the shared responsibility model works, right? So there's responsibility on both sides. And this is very, very important to know before you build your cloud application or host an application in the cloud. Now we'll start with data classification and encryption, right? So anytime you are storing some data in cloud, there are 2 things that you need to really, really be careful about. You have to encrypt your data that's sitting in your storage. You have to encrypt the data that's transferring between your applications and databases and other applications and APIs and whatnot, right? What we call encryption of data at rest, encryption of data in transit. And these are the first things that I would go enable in any company. By default, they're not enabled, so you'll have to go enable them to make sure your data is secured. And then the classification of data also helps in this case. Not all data can be seen through one lens. There will be some sensitive customer data. There will be some non-sensitive or less sensitive, company-wide data, like for example, HR data that's available for employees. It's available for all employees. Or there could be like a public website information that's available for the entire world. So at that point, you don't really have to worry about securing, that public data, but you don't at the same time you want to prevent the man in the middle attack before that data reaches the customer, right? So data comes in different shapes, different sizes, different purposes, and that classification is very important. Based on that classification, you can lay out a strategy as far as data protection is concerned. In large companies, there are hundreds of people who are dedicated to this job in terms of data classification, data governance, and ensuring that encryption standards are in place. Someone will be publishing those policies from enterprise architecture. Someone will be implementing those policies from reliability engineering, and someone will be governing them from governance and compliance bodies, right? Next is identity and access management, right? So identity and access management is very, very important in cloud. One of the major challenges that cloud is providing is it's actually, I would probably put it as an advantage and disadvantage. Pay as you go model will actually give more and more power to the developers to go control their servers behind the scenes or control the cloud resources behind the scenes. However, the greater responsibility comes with, the greater power also comes with greater responsibilities, right? So if you are a cloud administrator, it's your job to make sure you're providing only the privileges that the subject is going to have on the object. In other words, give only the minimum privileges that a developer can use and exercise to perform his or her actions. You don't want to give anything beyond that. And this is how the policies has to be written, and this is how the security groups have to be defined within cloud. At the same time, role-based access control is another area within identity and access management, what we call IAM. Assign permissions based on the user roles. When I talk about user roles, there will be a project manager, there will be a developer, there will be an architect or a group of developers, and there will be an architect, one or two architects. And at the same time, there will be folks like business users who will give the requirements, business analysts who will analyze those requirements, and an architect will go ahead and architect the solution out of it, following the enterprise guidelines. Developers will go code it, make it happen. There's a tester who is testing it. And then there's a project manager / agile scrum master or anything in those terms. They will be governing the execution of the project. You cannot give one unique permission to all of these users. Developers might probably need a little more privileges than the testers, than the architects, and project managers might only need like a read-only access just to see what's the progress of the project, right? So if you look at it, that role-based access control, what we call RBAC, is very prominent in IAM. And then multi-factor authentication. So there's something called New York Department of Financial Services, NYDFS in USA. So that's a regulatory body for financial services. They have come up with a new regulation. What it says is if you want to do financial business in New York, like if you have a bank that has let's say a branch in New York, you'll have to follow our guidelines, right? And those guidelines actually mandated multi-factor authentication. This is much popular in India as well. When you log into your bank account, you'll probably get an SMS, and on one side you put a password, on the other side you put the token that you receive in SMS, and then you get authentication. Now, multi-factor authentication has also challenges on its side. There are so many scams that are happening where people are asking for these SMS codes and getting access to your account. So be careful when you share those SMS codes. Um, I've seen so many TV, advertisements in TVs and whatnot. So educating your customers is very, very important in this sector. At the same time, introducing multi-factor authentication will provide an additional layer of authentication. So, the whole IAM principles play a very key role in cloud security. Defining IAM policies and best practices is where I will start. When we start working on implementing IAM, I should probably define policies first and review those policies with appropriate owners in the company, and then start from there, and then implement the policies once the policies are approved. At the same time, never trust what your users are doing, and always make sure you build this audit trail that will monitor the user actions. Just because someone has a privilege to go delete an EC2 instance, for example, or a server on a cloud, they should not be exercising that right without proper controls in place. And audit trails are very, very important. Key management is another area. When you're talking about encryption mechanisms, let's say you are going in and building an EC2 instance in AWS, or a virtual server in Azure, or a compute engine in GCP. In the past, you were within the network when you're working on-prem, so you are completely a trusted user. You log in with your VPN and other sources into the network, so you're authenticated before you get into the network. Now, when it comes to cloud, it's a different ballgame altogether. So what you do is you generate keys, whether these are PEM files or PPT files. You generate these keys and you store those keys in a standardized environment. You don't want those keys to be sitting on someone's laptop, where if the person loses the key, someone else can get access to the system. So that key management is very, very important. All cloud service providers, as far as I know, they provide these key management services. And you'll have to make sure these key management services are used in the right way. They store the keys within themselves, and there should be a retrieval mechanism which will require further authentication. Like if I want to access a server in my company, I cannot just go log into it. I have to go to key management system first of all, and then tell the key management system who I am. And based on my authorization, I should probably go retrieve that specific key to log into this server, use that key to log into this server, and that key will be active for that session. Once I close that window, that key should be deactivated. And next time when I need to access the server, I'll have to follow the same process, right? So that key management aspect, the centralized key management aspect is a key. And integrated encryption mechanisms. So nowadays there are tons of mechanisms available. RSA algorithms are pretty famous. They used to do, I think, 128-bit encryptions long time back when I started this journey. Today they are doing like 2 gig encryptions. It's not easy to break these keys unless you bring in like a supercomputer from a different world, right? So encryption mechanisms, they need to be integrated properly, and the cryptographic algorithms that you are choosing to encrypt your keys, that's very, very critical as well. You have to choose the right level. There are some regulations in the industry mandating that you cannot go beyond like a 1024 key encryption, right? And the companies always try to stay above that. If not, they will run into trouble. From network point of view, what we call NACLs, NACL stands for Network Access Control List. This is very important as well. First of all, network segmentation is a whole different topic. When we're talking about network segmentation, it's a very large topic. So what you're doing is you're isolating your groups, network groups, into different areas. You can always build something in a less restricted space that serves web service that serves your website content, because website content is technically not private in nature. People can go to your website and see the content, right? But at the same time, you cannot go host your APIs in the same set of accounts or same set of network. That has to be pushed one level deeper, where additional layer of authentication authorization is needed. Similarly, the way you install firewalls in your network is very critical, and how these firewalls act is also very critical. We build these different set of account groupings within cloud and install these firewalls with different settings. For level 1, there will be less restricted access, and if you go to level 2, level 3, there will be more and more restrictions. Even the company developers should not be able to go access these. So we talked about NACLs, we talked about network segmentation strategies here. Another aspect of it is security groups. So security groups is basically grouping the policies together and applying them. For example, if you are spinning a resource in cloud in a development environment, test environment, and production environment, they should follow different security groups. Development environment or the POC, proof of concept environment, should be much more liberal in nature, because you will probably want to go try out different things before you finalize your solution. So it should be less restrictive. And during the development phase, you want to go perform multiple builds, multiple changes into your application, the applications that you're working on. So it will be a little more restrictive compared to your POC environments. And then as you go to test environments, you should not literally perform any changes over there directly, because it's for testers to go perform their QA activities. And when everything is ready, you got a green signal to go live with that application that will go into production. Now, when you go to production, just because I'm a developer who developed the application, that doesn't mean I should have access to that application completely in production, because in production, you are dealing with customer data, really sensitive data. As a developer, I have no business to go access that data. So I should be restricted accessing production environments, right? So that's the background about security groups. Threat detection, monitoring, and incident response. Cloud activities, there are multiple activities that go on in your cloud account every single day of your usage. You want to make sure you're logging that activity, you want to make sure there's a trail of log that you're maintaining in this, in this day-to-day activities, right? Because if you don't do that, when an incident happens, you will be really struggling to find out the root cause. This is the reason why you have to log your API activity. You want to make sure your cloud resources are monitored. If someone has an access to perform a change in network access list, right? So the NACLs, you really want to know who performed that action, and make sure you generate an alert immediately if it is a non-authorized action, right? So that monitoring, the cloud monitoring, is very important. There are services that these cloud services provide, service providers provide, so you'll have to make sure you use them. Like CloudWatch is one of the services that I can think about in AWS. CloudTrail is another service. So you have to make sure the services are implemented properly, the alerting mechanism is implemented properly, and the anomalies are detected properly, and make sure whenever there's an incident happening, you should be able to go pinpoint the problem. And then enhanced security visibility. So proper configuration is important for these monitoring services. At the same time, reviewing those configurations is also important on a periodic basis. Just because you implemented a solid policy 2 or 3 years back doesn't mean that policy will work today. The landscape is changing. AI is changing the way we are doing our business today. And apparently in the past, when we were developing applications, we were worried about cross-site scripting within a web page. Today, we have to worry about prompt injection attack if you are using Gen AI or chatbots. And our landscape is changing constantly. So what the configuration that you did like few years back might not apply today. So periodic audit of your configurations is very, very important, and make sure that reflects to your current usage and current trends, in your use cases. See what slide we are in. Yeah. And then integrating cloud threat detection and security services, software like CloudStrike, and there are tons of softwares nowadays, for threat detection, for managing security services, like SSM is one of those things I can think about. Threat intelligence and machine learning. So these services are also utilizing and getting enhanced with AI in the background. So these services leverage threat intelligence and machine learning, to accurately predict what's happening and then send real-time alerts. At the same time, security findings, right? So security hub services, they are providing that visibility as well. Generally, companies run third-party software for vulnerability management, um, and 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 vulnerability management itself is a bigger topic, right? So you need to make sure you're identifying all the vulnerabilities in your environment and reporting those vulnerabilities. Someone will consume those reports and build appropriate steps to go mitigate those vulnerabilities. So building that ecosystem hand in hand is very, very important. You have to create that visibility around the security findings. You should also have mitigation steps, to address those findings or to address those risks. And there are some areas where automated detection response is important. For example, you probably have, um, you know, an account in a cloud service provider, and then you have multiple lines of businesses within your company. You don't want to go club all those lines of businesses under one account. So what you normally do is you implement something called a service control policy, and then you create sub accounts for those line of businesses. So you isolate those line of businesses. Yes, they can talk to each other, but in a controlled way. At the same time, your test environments, your development environments, your production environment should not always be part of one single account. I mean, there should be some sort of isolation that needs to be done. If a particular instance is compromised, you should be in a position to go quarantine that account. So that way, that problem does not spread to more critical systems. So addressing that concern is very, very important. So that isolation is important as well. As you detect a threat that's happening within your system, you should be in a position to go quarantine it automatically. You should not wait for a human to jump in and run a bunch of scripts to do that. So that automation, is important to build too. And then automated incident response playbooks. A good example would be something like Azure Functions or AWS Lambdas. There's a reason why these serverless technologies exist. You find an incident, you can build automations based on that incident where these functions, these cloud functions will act on your behalf as an agent and go address the problem and then let you know that, hey, I found this problem, this is how I addressed it, and I'm letting you know for your information, right? That's the right place to stay rather than just getting an alert and then acting on it manually. This will also minimize the incident impact. So that way, your incident is not widespread where your customers are getting impacted. And it will also enhance your security operations. So automation enhances security operations, improving their efficiency, especially by reducing manual intervention. Then DevOps is another topic that came up, I think right around 15 years back, I think, and then it got a lot of maturity in the first 5 years. This is where you are going to build or automate your builds, automate your deployments, what we call CI/CD, continuous improvement, continuous deployment strategy. So that's where DevOps came up. The new buzzword on the street is DevSecOps, what we call secure DevOps, right? So we call it DevSecOps. And DevSecOps plays a very, very key role in terms of your cloud maintenance. At the same time, you have to make sure you build a zero trust policy. Don't trust anyone. Don't trust any traffic in your cloud environment. When you're running in a data center, it's a whole different story versus running your applications or migrating your applications to cloud. Cloud is, you can restrict it as much as you can, but by default, you're exposed. So you have to make sure that cloud implementations are done right. And when it comes to securing your CI/CD pipelines, the DevSecOps topic that I talked about, incorporating automated security checks, within the pipelines is very important. And let's say you have built an API function or an API, and that API is actually retrieving some information from a critical database and handing it over a SOAP or a RESTful call to the user. If you don't encrypt that data during the transit, you are compromising your API call. So having those checks and balances maintained in the automated scripts is very, very important. And this will ensure your vulnerabilities are detected early in the development. So building that intelligence into these pipelines is very important. Vulnerability scanning, this has to be part of your day-to-day job. It should not be a religious activity that you perform once a month or once a quarter. It has to be real time. It has to be a day-to-day operation. So there are tools available in the market today. Wiz is one of those, Sneak is another one, and there are tons of tools that are available in the market. So leverage those tools to make sure your vulnerability scanning is part of day-to-day activity. There are different sets of tools available for infrastructure scanning versus your code scanning. Today, we have sophisticated tools in the market where you put your Aadhaar card number in plain vanilla text. It's going to identify that, hey, you are revealing sensitive information here. This is not encrypted, so you have to go encrypt it, right? So it will treat that as a vulnerability and log into the appropriate system for visibility. So there's code scanning that's happening. There's infrastructure scanning that's happening. Leverage those systems, make sure you implement those systems with the right set of controls in place. So that way you're not compromising on either side, whether it's infrastructure or applications. And strict permission management is very important. We talked about role-based access control. That's something that you can implement here, where you restrict access to pipeline components only to the people who know it, or only to the people who are authorized to use it. By doing all this, you can enhance the security posture across your CI/CD pipelines. Automated compliance check using cloud configuration and audit frameworks, right? Audit is a very critical component. Never ignore your audits. Cloud config services, they monitor resources, but end of the day, you'll have to report those resources, and someone needs to look at those resources, govern the policies, and make sure those audit findings are appropriately addressed. There are automated auditing tools. For example, we talked about vulnerabilities, reporting. You can build a little bit of intelligence into vulnerability reporting, and then perform automated audits. Regulatory framework adherence, and this applies more towards different industries. Like if you are doing business in India in healthcare, you have certain regulations. If you're doing business in India for banks and financial institutions, there's a different set of regulations. So you as a technology expert, it's your job to get familiarized with those regulatory bodies. We cannot say it is non-technical topic, I'm not interested, right? That's not how the real-time jobs work. You have to make sure you learn that side of the regulatory body, based on the industry that you're working. As I talked about one of the examples at the beginning of the call, I said NYDFS, New York Department of Financial Services. You need to understand what those regulations are so that you can take care of them, when you're implementing your technology. As I talked about, like a multi-factor authentication is a bare minimum requirement over there. So if you want to do business in New York, you'll have to follow those regulations, right? So similarly, understanding that industry regulations and adhering to that regulatory framework is very, very important. So you should never ignore that as a developer, as a commercial developer. And then IAC is another topic, infrastructure as code. In the past, there were WANs in the network. Now we call them SD-WAN, software developed, wide access network, right? So when you're working in cloud, sure, you can go to the console and then spin resources by clicking, a few mouse clicks. But in real time, when you have to go spin 100 resources, you don't go spin them manually. You actually go write scripts behind the scenes that will actually trigger these automations behind the scenes, and then they will provision the resources based on the configuration, based on the code that you are providing, right? So a very popular tool in this industry for IAC infrastructure as code is called Terraform. Some of you might be familiar with it. It's a very descriptive language, easy to learn language. So integrating security mechanisms directly to this Terraform templates is very important. Making sure you protect your Terraform templates so that way those templates doesn't go into the bad hands. At the same time, providing authentication and authorization for those respective Terraform templates that will be executed is very important. So you need to secure all that area. And you can integrate your IAC or infrastructure as code into standard pipeline management, standard CI/CD pipeline management. You can build two pipelines. On one side, you will provision your resources in cloud. On the other side, you will go deploy you'll go and build and deploy your application. So maintaining those pipelines side by side and securing them is very critical for this automation. Frequent code reviews will help. As I said, anything that you built 2 years back, or probably say go re-review it back, and make sure you built in a discipline that you do your code reviews once every 6 months at least. And these are some advanced topics, zero trust and emerging security practices. So zero trust is pretty popular buzzword in the industry today. Adopting zero trust architecture in cloud is something that the companies are moving towards. What zero trust means is, as the name says, zero trust, don't trust anyone, right? So continuous access verification, selecting, proper identity verification, and making sure your network segmentation is done right. At the same time, access permissions in real time based on the user context. Let's say there is a production issue going on and your customers are seeing the impact. You have a reliability engineering team to go address it. If the reliability engineering team has to access these systems in production, they should not have a free pass to it. They should probably take that incident that's happening and use that incident to justify in an automated fashion to get access to production instance for that particular window, whether it's 1 hour or 2 hours. And after that, they go fix the problem. The engineer fixes the problem. And then when the person comes out of the system or logs out of that system, that person should not have access again. So restricting this access and making sure you're implementing dynamic access controls, what we generally call, the industry term is, it's called break glass access control. So imagine you have keys to a house and it's inside a glass and there's an emergency going on. You have to get access to it. You break the glass, get the key, and then open the door, right? So that's the concept we implemented in the security world as part of this zero trust architecture. Microsegmentation and least privilege enforcement. I cannot stress enough on the least privilege enforcement. Network microsegmentation, what we call network segmentation in the past is now called network microsegmentation. So more and more scrutiny has to happen when you are separating these systems based on the use cases, based on the sensitivity of the data that they're handling. And you're not acting on one widely available network. You're dividing that network into small pieces and then applying multiple policies, or you're changing your policies as you traverse from one network to another, right? So that micro-segmentation is very, very important. And these are happening in the real time as we speak. Many companies are actually implementing these. Least privilege enforcement, as I said, very critical. Enforcing the least privilege, restricts to what I call need to know basis. And continuous security posture management um, is very critical for the company. Don't make security as a religious activity. Make security as a day-to-day activity, right? And that's how much importance you have to give if you want to stay in business. Managing the privacy of your customers, managing the security of your systems. Continuous monitoring is important, as we talked about. Automated posture management. This enables security protocols to or security policies to make some adjustments without actually a human going in and altering it. So this is where AI, artificial intelligence that is being built into the security systems, is trying to address. It's enhancing, the overall efficiency of these security systems by taking some decisions without manual intervention. Um, and AI and adaptive control. So integrating AI, is very important, and that's happening at a large scale across many cloud providers, or even security providers for cloud. Anytime a vendor walks into my office and wants to sell some software, the very first question I have is, show me what you have done in the last 6 months in your product before I can even go look at the product. And if they say these are the AI capabilities are built in, that's a selling point today. Enhance automation in cloud. Obviously cloud and automation go hand in hand. Security controls can be automated, and security incidents will probably need to work at least 80-20 rule, where 80% of your security incidents are automatically addressed, and 20% of the incidents will probably require manual intervention. So that's the equation that I would draw. If you are not doing that, then your maturity of the cloud needs to be improved. So with that said, the conclusion here is what I'll draw, right? Multi-layered security approach. Always make sure you build effective cloud architecture, separating or segmenting your networks, micro networks, making sure you build those quarantine mechanisms in case if there's a compromise that happened on your account or one of your sub accounts. Threat detection is critical, but at the same time, what are you doing or how are you acting on the detected threat is very, very important. Securing your DevOps pipelines and providing that robust protection is very important. Proactive threat detection, don't wait for someone to hack into your systems. Try to hack yourself before someone else does it. There's a quote in the industry, especially in the marketing industry. If you don't disrupt yourself or your product, someone else will disrupt it, and it's going to come from some corner of the world which you least anticipated. So always make sure you hack into your systems and find out the gap before someone else does it for you. So that proactive threat detection is very important, and AI is making it possible. So understanding how these systems work, and understanding how the artificial intelligence is integrated into these systems is very important. Emerging practices, as I said, in the past, when I started my career, I have to mention that creating an HTML page itself was a job. Now today we don't need it. I mean, we have softwares like Wix that can actually do it in 5 minutes. And if I go talk to any Chat GPT or Claude or Gemini, it could probably create that script in a minute for me or less, right? So that's how fast the industry or the technology landscape is changing. If you build a policy back in 2000 and you're still relying on that policy today, that policy is obsolete. it's obsolete, so go ahead and throw it away and then rebuild it, right? And you have to constantly keep up with emerging practices, emerging threats, and make sure you revisit, you review your posture management, your security posture management, and adjust accordingly to ensure you won't become a victim, but you're proactive and addressing those gaps before they actually show up on on your side or on your customer side. So with that said, I think I spoke enough. If you have any questions, let me know. And I think I even shared my email address on the slides. I'll go ahead and share these slides with Venkatramulu, and feel free to contact me if you have any deeper discussions that you want to have. And thank you for the opportunity. It's a pleasure presenting this stuff to you and sharing my knowledge across the industry. Venkatramulu, back to you. We have another 3 minutes left, so if anyone wants to ask any questions, feel free.
Dear participants, if you have any queries, you can also ask.
Okay, someone came out of mute. And that's fine, right? I mean, if you don't have to ask in front of the audience, just feel free to contact me via email. And if I know people are from different colleges, I believe, here. So if you need any further presentations in the future, let me know. I'd be happy to do it. This is my way of giving back to the community. Sharing my knowledge, sharing my experiences. I always love to do it. But thank you for having me on this call. Okay, we are right at the hour, so
Yeah.
I'm logging off. Yeah, thanks for the opportunity.
Yeah, thank you, Santhosh, Pasula. We are very happy with your session. You have given the good inputs on AI and cloud security. Yeah, thank you very much joining us.
All right. Yeah, I'll have a good evening. Thank you. Bye.
Yeah, thank you.